Here. So if we take a look at these triangles, again, what you learned from yesterday in terms of constructing them with our little poly strips. Like if you take a look at these two right here that we matched up, okay, what's the only difference from the left side to the right side? Maria? It's rotated, right? Are there any up there that don't look like they match? Maria? This one? All right, so let me see if I can pull this off. Watch this. I'm going to try to trace this as best I can. Let's see if this works. So if I take this, oop, I'll get the other piece here, and I rotate it. Kind of cool, huh? Is that the same? It is, isn't it? They just rotated it, so it looks a little different. Okay. When I went and observed a classroom the other day, someone said this one didn't look the same. So let me see if I can do this all in one motion. That way, it should all go together. There. So if I try to bring this guy over, there it goes. Right? Someone said that this one didn't work out. Well, again, because it's rotated, it looks a little different. But if you look, it's the exact same shape, isn't it? So sometimes when they rotate, you change the angle. Now, you kind of figured it out yesterday because you had some sides that you maybe thought worked but didn't connect, right? All right. So, and again, I can't draw like some of you try to figure out. You can't make another triangle, right? Like this one that I just slid over here. I can't make it into this one, right? Or this one. I can only make that one triangle, right? Same thing with the one that we did up here, right? I can't make out of the same dimensions different triangles. I have to have different dimensions, right? So if we go to the chart that we did, okay? So time to share your results. So the 16, the 6, 10, 15 one, could you make a triangle with those dimensions? Yeah, everyone said yes. Could you make a different triangle? No. All right. What about the 18, 9, and 4? No, you couldn't make a triangle out of that? So could you make a different one? No, if you couldn't make a triangle out of the first set, how can you make a different one, right? All right, good. What about the 5, 15, 5? No, you shouldn't have been able to make one. If you're able to make one, you obviously changed its dimensions or you bent it. Remember, you can't bend them. So that's a no. What about the 11, 11, 10? Yeah, that was a yes. Could you make a different one? No. A different one meaning the same dimensions. You can't. It's the same triangle. Again, if they rotate, it's still the same triangle, right? All right, what about the 497? That's a yes. Could you make a different one? So we're kind of already seeing about the different triangles, right? What about 28 and 12? Yeah, that was a no. 558? Yep, that was a yes. And then what about the last one? 3, 5, 12. Okay. So here's my question to you. What pattern did you see that explains why some sets of numbers make a triangle and some do not? Do you see any pattern there with the yeses as opposed to the nos? Okay, the sides are closer. Okay, anything else? No one saw any other pattern? Aiden, do you see a pattern? No? let's compare a yes to a no. Let's look at these sides here. I'll compare these two. Okay. I guess I'm going to have to let the cat out of the bag. So if you add the two smaller sides, all right, and it's smaller than the biggest side, or the biggest number, you get a no. If your two shorter sides add up and get a bigger number than the longest side, it's a yes. So watch. What's our longest side in the first one? 15, right? So is 6 plus 10 bigger than 15? Yeah, it's 16. That was a yes, right? Look at the next one. The longest side here is 18, right? Is 9 plus 4 bigger than 18? No, that was a no. Let's try with the next one. Here's our biggest side, right? Is 5 plus 5 bigger than 15? Nope. What about this yes? What's our biggest side? 11. So is 11 plus 10 bigger than 11? Yep. What about this one? Here's our longest side, right? 4 plus 7 bigger than 9? Start to see the pattern? What about 20? 20 was our biggest side. Is 8 plus 12 bigger than 20? No, it equals 20, right? So as long as if it's not bigger, it's a no. All right? Okay, 8 was our longest side. 5 and 5 is bigger than that. So you see the pattern there? So basically, if we write this out, so if the two smaller sides add up to be, we'll say less than or equal to the longest side, then it's not a triangle. Right? So then we want to say if the two smaller sides add up to be greater than the longest side, it's a triangle. Let's see if I can fit all this in here. Okay. So, and then B2, we kind of answered that question in the last column, right? For what side lengths can you make more than one triangle with the given set of side lengths? None, right? You cannot make another triangle with the given side lengths. You can only make one, right? Only make one triangle. All right, so I'll give you a second, guys, catch up and write all that down. That was a lot. So that pattern, again, so if the two smaller sides add up to be bigger than the longest side, you can make a triangle out of those sides. If it's less than or equal to, you cannot make a triangle. Unless you cheated and you bent them or you did whatever you could to make it work. Okay? Anthony, did you give me your quiz? Did you put it up here? Thank you. All right, everyone with me? Everyone got it? No? Okay. I'm going to go here then. While we're waiting for everyone to kind of catch up writing, I'm going to pause the video. All right, so if we go to the next slide here, under summary. So, lots of important information here. So, in order to form a triangle, the sum of the two shorter sides must be more than the longest side. That's kind of the big thing from this, right? From what you spent all day yesterday doing. So this is going to go in the summary part of on the back sheet. So again, they kind of give you an example here. So a triangle that has three sides measuring 5, 7, and 10. Well, if the longest side is 10 and the two shorter sides is 5 and 7, 5 plus 7 is 12. So 12 is more than the longest side of 10. Therefore, you can make a triangle. Okay? And then you want to get this one in the green too. In no case can a given set of side lengths be used to make two different triangle shapes. You can only make the one shape. Okay? You can only make the one shape. Again, we discovered all that yesterday, right? All right, so while you guys are writing that down again, I'm going to pause this just so we don't have a lot of dead space. Okay. So, in terms of the review, all right, move this up just a little bit. So, equilateral triangle. Okay, we've talked about these, right? Just try and get them down. So, an equilateral triangle has three equal sides and three equal angles. Okay. Make sure we're recording. Okay. An isosceles triangle has two equal sides with two equal angles. Okay? Just get them down right now. Scalene triangle. No sides are equal. And if no sides are equal, what does that mean about the angles? They're not equal either. Okay? If you have a right triangle, that means one angle in a right triangle is 90 degrees. Doesn't matter what the other 2 degrees are. If one angle is a right angle at 90 degrees, it is a right triangle. All right, an acute triangle has two acute angles. Who remembers what an acute angle is? Anthony? Any angle less than 90 degrees. Good. So it's got to have two angles in it less than 90 degrees, basically. Right? So an obtuse triangle has one obtuse angle, which means that's an angle what, Maria? More than 90 degrees. And then don't forget the angle sum of a triangle. All the angles, which are, how many angles are in a triangle? 3 have to equal 180. Can't be bigger, can't be smaller. It has to equal 180. Okay? All right, again, we're going to pause so you guys can get this down. What you've learned here. So here's a little scenario for you. You don't have to write this down. Okay? So it says I have two side lengths of a triangle, but the third is missing. The two I have are 4 and 8. So Sally says the side length could be 11. Is she correct? Why or why not? Of a triangle. What do you think? Some people said yes right away. Why? Maria? I don't know, is it? Good. So yeah, remember when they talked about having a triangle, the two smaller sides when you add them together have to be bigger than the longest side, right? So if the longest side is 11, and if you add the two smaller sides together, isn't 4 plus 8 12? And isn't 12 bigger than 11? So yeah, she could be correct. Okay, it could be 11. It could be 10. Obviously, it can't be less than what number? This side can't be less than what number? 8, right? If it's 7, That's not the longest side anymore, is it? Okay, does that make sense? So take a look at these other side lengths. These side lengths right here. Could that be lengths of a triangle? Why? All right, some people said yes, some people said no. Why yes? Where's my yeses? Why yes? Why no? Jason? Yeah, this is it's a no, and the reason being because basically 2 and 6 add up to 8. 8 equals 8. That's not bigger than 8, is it? So if it's less than or equal to, it's not going to work. So that's a no. What about the next one? Why? All right, it is yes. I'll give you that one. But why? What is our reason for yes, Aiden? Yep. What is 12 plus 7? 19, right? And 19 is greater than 18. So when you add them together, that's bigger, right? Good. What about the last one? 22 and 19. Braden? Right. 21 is bigger than 20. All right, good. All right. Here's what I want you to do. Either with a partner or on your own, I want you to make 3 sets of sides that, I'm not going to worry about this part. I want to see if you can, I want you to make 3 that are yeses and 1 that's a no. Okay? So 3 sides that would make up a triangle and then 1 that wouldn't. So, okay? So we're going to pause and we're going to give you guys about 4 or 5 minutes. Now, either with your shoulder partner or you can try this on your own. All right, go. All right, let's see here. Who's going to, Joey, give me one of your triangles. 2, 4, 5. Everyone agree that's a triangle? Yeah, because 2 plus 4 is 6, and 6 is greater than 5, which is the longest side. Perfect, that's 1. How about, let's see, Philip? 9, 18, and 7. Okay, so here's our longest side, right? Is that a yes or a no? Okay. That was on your no. That was on your no triangle. Okay. Yep. Perfect. Right. Because here's 9, 18, and 7. So 9 plus 7 is 16, right? And 16 is less than 18, which means that's a no, right? All right. Very good. All right. That means now you got to come up with the people are calling. You got to come up with the yeses. Rebecca. 3, 6, 10. That's a yes one. Is this going to work? Longest side is this, right? Is 3 plus 6 bigger than 10? So what can I change to make it work? Rebecca? Shh. What can I change on these smaller sides to make it work? Or the longest side? Change a 3 to a 5? Okay, does it work now? Yeah, 5 plus 6 is 11. 11 is greater than 10. All right, last but not least, Ashley. 20, 15, and 7. So there's the longest side. Does this work? Yeah, 15 plus 7 is 22. 22 is greater than 20. All right, excellent. All right, now we'll see how well you remember your vocabulary. Ready for this? All right, so come up with 3 side lengths for an isosceles triangle. What's an isosceles triangle? Lots of hands up. Okay, good. Ava. All right, so they have to have 2 equal sides, right? So 2 sides have to be the same. So what do you think could satisfy that? But it still qualifies as a triangle. Don't forget our rule. Anyone got an idea for me? Isosceles triangle. 2 sides have to be the same. Anyone have one? Martina? 12, 12, and 2. So one of the 12s is our longest side, right? So 12 plus 2 is 14. Is 14 greater than 12? Yep, that would qualify. And again, we got two same lengths, so that would work. All right. How about side lengths for a scalene triangle? What is a scalene triangle? Braden?
No sides are equal.
So not one side can be the same number. Anyone got an idea for that for me? Isabel.
10, 3, and 9.
Okay, so none of those are the same, right? Does that qualify for a triangle? Why? Where's our longest side? 10. So is 3 plus 9 bigger than 10? Yeah, it's 12. Perfect. Perfect. So, there's your homework that you got 12 minutes of class time that you can work on. So I'm going to stop the video here. Just 1 to 5.